Only the very best A-level maths students scored the final mark in this question. Will you be amongst them next summer? In their report after the exams, the examiners said that a number of candidates lost all of the marks on this question by not even attempting a solution. And in fact, whilst most candidates scored the first 2 marks, only the very best were able to score the final mark. And in fact, it was clear that not all students even understood what an obtuse angle was. How embarrassing, that's GCSE, isn't it? What does the question say? A student attempts to answer the following question. Given that x is an obtuse angle, use algebra to prove by contradiction that sine x minus cos x is greater or equal to 1. What do we mean by obtuse? Remember, obtuse means that the angle is between 90 and 180 degrees. Here we have a proof by contradiction. Let's see how the proof starts. It says, assume that sine x minus cos x isn't greater or equal to 1. What's the opposite of that? Well, that's less than 1. Note the strict inequality here, not including 1, when x is an obtuse angle. So we're saying, yeah, this is true, but this is not true. What have they done? They've squared both sides of this, right? They've squared the left-hand side to get this, and they've squared 1 to get this. We need to complete that proof. How can we get started with this? Well, we can expand these square brackets. If you do that carefully enough, you'll end up with this, and that gives you your first mark. Next, you can note that sine squared plus cos squared equals 1. So we can replace the sine squared plus cos squared with the number 1. That gets you your second mark. Then we can subtract 1 from both sides. That would give us a 0. And then if we just tidy it up by adding this to both sides, we'll end up with this is greater than 0. Next, we can tidy it up further by dividing by 2 to end up with a product. I'm just going to write that the other way around. So it says sine x multiplied by cos x is positive. So we know that product, that multiplication of 2 things, must be positive, or at least that's the claim. But remember, x was obtuse. That meant x is between 0 and 180 degrees. But if you think about the graph of sine x between 90 and 180, well, sine x is positive. But cosine x between 90 and 180, for obtuse angles, is negative. So we've got something positive, sine x, multiplied by something negative, cosine x. What's that going to give us? Well, it's going to give us a negative result, not a positive result, as it says here. So that's our contradiction. We say that this is a contradiction as sine x is positive, cos x is negative, and so the product must be negative for obtuse angles between 90 and 180. Don't forget, we need to state the conclusion. Think about what we were trying to prove here. We were trying to prove this result. So you say, therefore, this result is true. You can just copy it down. Make sure you do that to get the third and final mark. Is there another way of doing this? I think there is. In fact, we can do exactly the same things to begin with, but then you can notice that at this stage, we've got 2 sine x cos x. That should be familiar to A-level maths students. If you know your trig identities, you should recognize that as sine 2x. So we're saying that sine 2x must be positive. Remember, this was for obtuse angles, where x is between 90 and 180 degrees. We know the graph of sine x. How does that compare to the graph of sine of 2x? Well, the 2x here is going to divide each of the x values by 2. So where we had 180 before, for example, it's now going to be at 90. Where we had 360 before, that's now going to be at 180. So the entire graph gets stretched by scale factor a half, parallel to the x-axis, horizontally. All of the x coordinates get multiplied by a half. Here's a slightly cleaner looking sine 2x graph. Remember, x is between 90 and 180, obtuse angles. Look at the graph. Sine 2x is negative there, not positive as it says here. So that's our contradiction. We can say this is a contradiction as sine 2x is negative for obtuse angles between 90 and 180. Don't forget, once again, you need to restate the conclusion to get that final mark.